Hey everyone, welcome back to my channel. If you are new here, don't forget to like, share, and subscribe for more content on data engineering, Spark, and optimization techniques. Today, we are diving into part 2 of Spark optimizations like repartition versus coalesce. So, in the last video, we covered the basics of these two operations. So, if you haven't seen it yet, check the link in the description. So in this video, we'll explore the practical use cases, performance differences, and some best practices when using repartition and coalesce in Spark. To quickly recap, in part 1, we discussed the core concept of these two transformations. Here is a slide to help you to understand more about the difference between the operations. So on the left, we have unevenly sized datasets with a total size of 150 MB, which is split into partitions of various sizes like 2 MB, 4, 14, 20, and 110 MB. So when we apply repartition of 5, Spark evenly distributes the data into 5 partitions of approximately 30 MB each. This involves a shuffle operation to balance the data across nodes, which can resolve skew but incurs a performance cost. In the contrast, coalesce of 3 reduces the number of partitions to 3, but it does not trigger a shuffle. Instead, data remains in the existing partitions. So, we might end up with partition of sizes 2 to 4 MB in partition 1, 14 to 20 MB in partition 2, and 110 MB in the partition 3. This can lead to uneven distribution but avoids the overhead of a shuffle. So, in summary, repartition is great for redistributing data evenly, while coalesce is better for reducing partitions without triggering a shuffle. Now let's analyze these techniques by performing code example using Databricks. Let's start by creating a skewed data in Databricks. This will help us to understand how partitioning impacts performance. So here is the initial data set as you can see. So it includes individual records labeled from record 1, 2, 3, 4 and the corresponding IDs like 1, 2, 3, 4, 5. So here we have created around 500,000 record and few distinct record to show the skewed dataness of the data. Now we'll check the default partition distribution and the record count. By default, Spark has created 8 partitions for this dataset, and additionally, the record count is 1 million. Okay. Now let's write a function or define a function to calculate the size. So here, this function will calculate the size in bytes and convert it into megabytes. So by doing so, we can visualize the data distribution across partitions. So we'll use this function in subsequent step to analyze partition sizes for both repartition and coalesce. Okay. Now we'll apply repartition to balance the data across 5 partitions. So after applying repartition, so if you see here in the output, we observe the following distribution like each partition contains approximately 200k records with a size averaging 7 MB of data. This demonstrates how repartition distributes data evenly by introducing shuffle operation. Okay. Next, we use coalesce to reduce the number of partitions to 3. Here, the result of applying the coalesce, the first partition contains around 250k records, while other two partitions contain over 370k records, while the sizes are ranges from 8.6 MB to 13.2 MB. So unlike repartition, coalesce does not shuffle the data, leading to uneven partition sizes. Okay. Finally, let's compare the partition sizes before and after applying repartition and coalesce. So here we'll take the default behavior, repartition and the coalesce behavior and try to compare the number of records in the partition and the size to get a clear picture on the differences. So here in the output, if you see for the default operation, we have seen 8 number of partitions, whereas in the repartition we have seen 5 number of partition in the output with 200k record for each partition on an average, and for college it is 3 partitions total with uneven of records. Okay, so if you see this final report here, the default partition contained around 124k records each. So after repartition, the data was evenly distributed into 5 partitions with approximately 200k record each. In contrast, Coalesce resulted fewer partitions with uneven distribution, as some partitions hold significantly more data than the others. Similarly for the sizes. Sizes for the default partitions are ranged to 4 MB, whereas for repartition it is 7 MB across the partitions, whereas for the Coalesce the sizes are not even, but it is also not evenly distributed. Now, let's quickly wrap up with when to use repartition and when to use coalesce. So, repartition is your go-to option when you need balanced data before operations like join or aggregation. For example, if your dataset is skewed during an ETL operation or an ETL pipeline, repartitioning helps distribute the data evenly across the nodes, ensuring better performance. Whereas coalesce, on the other hand, is ideal when reducing partitions without triggering a shuffle. This is especially useful when writing large dataset to storage, like Parquet or CSV, to minimize the number of output files and optimize I/O. Thanks for tuning in. So if you found this explanation helpful, don't forget to like, share and subscribe, and stay tuned for more Spark optimization tips in our upcoming videos. Thank you.